Hi guys, you're welcome to my channel. All right, today we're going to discuss about syncing and sourcing connection. Okay, in our previous exercise, we discussed about this particular sketch, this particular schematic. This is a typical representation of a PLC CPU, Siemens schematic 1200 S7. Okay, so I use AutoCAD software to bring out this because of those of my guys that are asking questions about CPU connection. Okay, all right. Take a look. This AutoCAD, like I showed you before, I use the software to bring up this. Okay, all right. Now we discuss about the input bit, the arrangement of how you can send your power to the input bit and send power to output bit. Okay, so today we're going to talk about two major methods of connecting your schematic, your program into CPU by carrying out the connection process. All right. Remember that we discussed about the power demand of the CPU. Let me make a recap now, please. Each of these bit, the power consumption of this bit, the power rating, shouldn't exceed the stipulated current rating to the nameplate. Like here now, we have 6 milliamp. So each of these bits should not exceed 6 milliamp. Otherwise, you interface the bit with a relay. I will do that interfacing after this exercise because I think we have talked about it a lot. So I will show you how to interface your input bit with a relay. Okay, so that you make sure that this particular rating, the instruction here is going to be complied while carrying out your connection process. Now let's go to syncing and sourcing. Now, for instance, let me first of all make the description before we go to our control software to see the CPU connection. Now, we all know that for electricity to flow, we must have live and neutral must have a closed loop, or positive negative must have a closed loop. Okay, you are also aware that we have a course set aside by IET, Institute of Engineering and Technology. There is a course set aside from this body called craft principle, electrical craft principle. Even if you don't have access to the course online, you can as well buy the book. The textbook is available. That textbook will put you through difference between life and neutral, difference between positive, negative, your Ohm's law, and the general connectivity, electrification process, and conduct, and the safety associated to electrical craft. So that course will teach you this basic electrical craft principle. If you understand that, syncing and sourcing won't be any problem with you because that language syncing and sourcing has been creating a lot of trend even on the internet. Most people don't know different how to sync a connection or how to source a connection. It simply means live and neutral. Which of this particular live or neutral or positive negative, which of these terminal are you using for your input bit? For example, here now, I have my live to supply to all my input bit, all my switches. This is live. In that case, on my output, my neutral is going to come to the lamp for the circuit to be complete. If I use my live conductor here, also use my live conductor here, you will not have electricity flow because you don't have a closed loop of electricity flow. Neutral is here, live is here, both of them will conduct through the CPU communication. Now, if I use my live conductor to supply my switches here, what I'm doing is I'm syncing. Then neutral now go to the output here. That is, I'm syncing connection. Then if I do the opposite, use my negative to supply here, or I use my neutral to supply here. In that case, when I come to the output, I'm going to use the other opposite supply to do this other side. Okay, but syncing and sourcing means if you are using positive or you're using live supply for your supply bit, for your input bit, your connection will be syncing. If you are using negative or you are using neutral to supply your input bit, that is switches, what you are doing is sourcing. Now let's go to controls software. Let's do the analysis more better. Okay, now, this is the CPU we are referring to. This is my S7 1200 schematic Siemens CPU device. Now, like when that question was coming up from my friends, so I have to go to Google to make a research to find out why do we even need syncing and sourcing? Why not make a uniform connection method for every PLC device so that we'll not be having the confusion of syncing or sourcing? So when I now Google out, I discovered that even some PLC CPU accept the both connection. They accept sourcing, they also accept syncing. Let me give you example again. There's what we call polarity. Polarity is using positive to positive terminal and using negative to negative terminal. In that case, you are polarizing your connection. Now, some devices where you want to carry out your connection, they will put a warning that makes sure that you follow the right sequence of connection because the system is polarized. Then, because of that, too, some mistake by interchanging negative positive will now damage some electronics devices. Because of that, some machine or some electronic gadget will come with inbuilt polarized device. Okay, inbuilt polarized device inside the device, inside the equipment, they will put up a kind of a gadget, a circuit that will correct the wrong connection of interchanging positive negative. So if you put it wrongly by putting positive where negative is supposed to be terminated, putting negative where positive is supposed to be terminated, then there is a connection inside with a device that will correct, revise it the right way. Okay, now, because of that, I discovered that some CPU, some PLC has that function embedded in the PLC. So in that case, from the CPU, they will write syncing or sourcing, whichever one that is applicable, the system will accept it. So if you do it opposite, system will correct it internally. So in that case, it has a polarized function. Okay, that's like I said in quote, some CPU, not all the CPU, some PLC has it. I don't know if all of them have it. Okay, so be careful. Make sure you understand the syncing and sourcing connection method. Okay, but I just discovered during my research that some CPU PLC has that polarized function. So any of this connection is accepted in that CPU. Okay, but the right thing must be done. Please follow syncing and sourcing method. Okay, let me show you how to understand it. Now, look at this portion. I have 24 volts supply. This is my supply. Here is my 24 volts. Look at the terminal code. The longest one is my positive. Now, for me to feed my input bit, now take a look at here. Here is my internal circuitry of CPU. I just use this one. I use this software to draw this place. So recognize here now. Here, take here as my input card of CPU. Here, take this place as my input card of CPU inside here. Okay, now here is what I just set up to illustrate what is going on here, because you know that in PLC the communication method is by flashing, just flashing light. That flashing light is the transmission and connection communication method CPU uses. That is why the input bit and output bit, their current carrying capacity is very small because there's no permanent connection internally. The connection is always be just pause, same flashing, same pause, same flashing. By doing that, communication, transmission, or operation is taking place. Okay. All right. So because of that, I discovered that some CPU we have, look at this diode. This is reverse bias, this is forward bias. These two diode is a kind of the way of polarizing that connection internally. That is some of the CPU that has syncing and sourcing connection acceptable. So because of that, now if this connection is carried out, this one is positive, passing switch to my CPU input card. Then this is negative, passing switch to that same input card. So this input card accept these two connection. Either the connection pass through positive and come, or it pass through negative and come. This one pass through positive and pass switch to come. This one pass through negative and pass switch to come. Whichever connection that is carried out by a particular engineer, the CPU will accept it. Because of that, now there's a diode here to revise which of the function that is activated here. If you activate this one, this particular diode will be activated. If you activate this one, this other back of the diode will be activated. Whichever one that take place here, these two diodes, one of them must activate that your instruction to the CPU. But quite unfortunately, not all CPU will have this, but some of them have it. Okay. But in a summary, let me take it away. In a summary, make sure you understand the analogy of syncing and sourcing. All right. So this is what it implies. It implies that positive will pass through switch to get to your input bit. Then negative will pass through switch to get your input bit. If it passes through positive through switch, it's called syncing. If it passes through negative, come to the switch, it's called sourcing. Take note, both of them are two different sources. This one is sourcing, this one is syncing. Okay, this is syncing method, this is sourcing method. So whichever one that is being used, passing switch, come to CPU, is going to be accepted by some CPU. It's not going to be accepted by some CPU. Okay, so let me take away this diode, please, so that you will not misquote. Take it away. Take this to be your CPU. Okay, let's say this is our CPU. Okay, this is our CPU. CPU. Sorry, CPU. Now this is our CPU. Okay, so this CPU accept this, also accept this, whichever one that is applicable to a particular given CPU. If you buy Siemens, okay, Siemens 11 S7 1200 schematic Siemens. Okay, if you buy that particular Siemens, what we use there is syncing. We are using this syncing. We are not using sourcing. If you are using sourcing, it will be specified. Okay, all right. So that is what I want to discuss with us today. Then before we go, I will also another is going to be another exercise. I'm going to show you how to interface relay to your CPU and also interface sensor to your CPU. But let me round up this class now. Let me give you, like I said before, you are expected to understand electrical craft principle before coming into automation industry. Electrical craft principle will make you to understand what I just narrated between this. Okay. Now, should in case you don't know about electrical craft principle, let me describe what is happening here. Let me take away this so that I'll be able to simulate this. Otherwise, here, this particular logic will not allow me to simulate this because this connection is not accepted in this software because it's not a complete schematic. It does not have supply, no input here, no output. So it will not simulate. So let me take it, sorry. Let me take it away so that I will simulate to enable me simulate this other. Take away this. Take away this. Okay, now let's simulate this. Okay. If I don't simulate this, you will not understand the output. The output. Now let's simulate. Now I have my neutral to my lamp. I also have my light supply to the lamp. Now, like I said before, for electricity to get conduction, you must have a closed loop. You shouldn't have open circuit along your line. So let's simulate now. I close this switch, the lamp come up. I open this switch, the lamp go off. That was because I have continuity from lamp, from live conductor to neutral conductor. You must have a continuity. You shouldn't have open circuit for you to have electricity flow. So because of that now, if we are doing syncing and sourcing, you should have something like this. Let's build a circuit. Let's try and build a circuit. Take away this. Take away this. keep this one here. Let's break it into two so that you understand the CPU connection. Let's break this into two. Okay. Okay. Now I will break it into two. Now CPU now demand, PLC CPU demand that since this is the supply, this is my live conductor going to my input bit. So if you have more than one of these, if you have multiple input like this, you're going to line it up this way. Line it up this way. Sorry. Line them up. All of them must come from your supply. All of them must come this form. Okay. All of them must come this form. All right. So if I have something like this, the whole of this is going to be my input. My input is going to input bit 1, 2, 3, 4. Oh, sorry. I used the wrong switch. Let's use, um, just hold on, sorry. Um, okay. So if you have more than one switch, you're going to do something like this. So if your input now requires five input switches, five input bits, and there happen to be switches or sensor, whichever. Sensor is also a switch. So you're going to line them up to terminate from the complete one particular source this way. So you loop them like this. You're going to have this form. I'm trying to give you the CPU connection, please, of PLC. So this is the connection we did before to light up this. So if I have more than one input, more than one output to energize, I'll line them up this way. So in that case, now you're going to bring your output this place and also line them up here at the output side. So you partition your connection. That is why I said for you to come into automation, you must understand schematic, you must design, understand the schematic function, process function before you come to write code. Because after writing code, you are going to terminate your code to CPU. So terminating your code shouldn't be a problem because you write just like a musician. A musician write the song and go to studio and develop the song. So from your writing and your practicing, your rehearsal, whatever thing you do then yourself. So when you go to studio to release the album, it shouldn't be an issue with you because you write, you compose, you do everything. Even the organ player or the instrumentist or everybody, organ, guitarist, all of them, if they play the wrong tone to your singing, you will correct them. Say, no, 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 fine tune this, give me another tune it to give me another voice, this one give me another voice, because those voice have correspondency to your own song. The same thing is applicable to electrical career. You're going to design after designing it, you now go to CPU to write the program and also carry out the termination process. You're going to do all that. Because you do the design, termination shouldn't be a problem because during your design, you've been able to establish how the connection is going to take place. So during your connection process, it shouldn't be an issue, shouldn't be a taskful process to you because you design it and you are going to write the program and you're going to carry out the termination. Okay, so let's do that now. Now, let's take a look at this. Remember that I did something this way and light up this. I decided said okay, let me split the connection up because I want to use PLC to control this. No more manual control. I want CPU, PLC to control this. So what I'm going to do now is I want the whole of this to light up each of this, right? So in that case, what I will do, I will carry the whole of this and line up on my input. Each of them, they are going to activate different output respectively. For instance, this one activate this one activate this one activate this. So because of that, what I will do, I will also line up their neutral to them. So at the output side, this is my PSC. This is my PLC. Okay, this is my CPU. So let me put this CPU, please. Just a quick one. CPU. This is my CPU. Now, why is it a confusion? Now, CPU will do something like this. Will complete the connections for me. CPU, they're going to complete my connection for me. Okay, so the instruction is that click, just activate this, output will come up. Activate this one, output will come up. But now, let's simulate, please. This one come up. Sorry, all of them will come the same time because I didn't number them. This one is going to be S1, for instance. So I'm going to be S2. Let me tag them so that they will work individually. It's going to be, let me say 4. Let's just roughly put them. Okay, so these are their names. So let's simulate again. This one come up, this one come up with this one come up with this one come up with this one. Okay, you can as well change their colors. All right, now PSC will do that. So let's cut off this. Let's cut off this. Let's cut off this. You now see that completing the task for this to come up will be done by PSC. Your own is to send the instruction to the PSC. Tell PSC, please, at particular time, activate this for me. At a particular time, activate this for me. PSC will do that for you, okay? Sorry, let me take away this. All right, now, sorry, it's my CPU is not coming. Okay, now look at my CPU. My input pass through one particular channel to enter to go into CPU. Now, connecting these two, creating this continuity internally is the job of PLC. PLC will do that according to the instruction of the program you've written. Connecting this is not going to be by cable. I showed you something like this. I showed you a diode. Let me bring that diode again. I showed you something like this. I showed you something like this. I formed some. Let's see if we can form a thyristor or okay. Look at it. Now I want to form a transistor. I want to form a double transistor, a kind of, although don't worry, just don't bother about that. Take away this. Now you know transistor with LED light. Now there's going to be a medium in which PLC communicate to this output, but it must not be, it's not by connection, it's not by creating continuity here, it's not by creating continuity. You know lashing circuit, beautiful. Let me give example of a lashing circuit. You know about, like, let me do a lash. Let me create a lash. Let's just quickly put a lashing circuit. Um, just a quick one. Let's create a lashing circuit, okay? I have a lamp where um, I have a lamp here, okay? And just quickly, I have a contactor or a relay. Yes, I have a relay here. I have a source. I have a source. I have my supply here. I have my neutral here. Okay, just a quick one. Just hold on. Okay, now let's create a lashing circuit. let's create, let's say, if you understand lashing circuit, okay, that is what we're going to create now. I want to use lashing function to describe how CPU communicate to your input and output bit. Okay, let's just create a um, let's just make a simple lashing circuit. Okay, now this is arrow one. Let's say arrow one. This is also arrow one. Okay, now let's simulate this. Okay, now I want to put on this lamp, right? Now watch this one. This is a momentary switch. It does not maintain. This is a spring loaded switch, a spring return switch. It does not maintain. Once you activate it this way, it will maintain, it will click and return back. Okay, let me change this lamp to yellow. Yellow is always sharp. Okay, just look at the function of this switch. Once it closes and you off your finger, it will bounce back to original state. So it just momentarily flash and go back, flash and go back. But once it flashes, it will send signal, it will activate a command. So watch, this lamp will come up. As I activate this lamp is working now. Now it just flash and send command and bounce back and this lamp come up. So that flash instruction is what CPU uses to communicate to the output. Okay, have you understand it now? Now, by flashing bit here, this CPU, there is an internal circuitry that does that function. Just flash according to the instruction, according to your instruction of the code. Put on this by so time. It will just flash when the time elapse. It will flash and give this. Once a flash is a return back. It does not maintain that instruction. That is why the current carrying capacity of the input is very is not significant, very small milliamp or at most 2 amp, at most 1.5 amps. That is the current carrying capacity of this CPU input. Meanwhile, the PLC can take 1000 amps, 500, a load of 1000 amps. You understand me? You get the point now. You know the magnitude of 1000 ampere. This CPU can carry 1000 ampere, but it does not bound the load. The current carrying capacity of that particular load demand does not bounce on PLC. PLC just flashes the command. The other different panel with other component, contactor, and all the rest will take care of that load. But the instruction will come from CPU PLC. Instruction will come in the form of what I just illustrated by flashing this and go out, and the load take over. You see that the current carrying capacity of this does not rely on this again. It relies on this. So this one just rests. So this is the command coming from PLC. All right. Thank you. Please share this to your loved ones, your relative, your fellow student, and so on, who may be utilizing this opportunity more than you. Please, thank you.